we are once again inside of the sublevel, and what I want you to place is a subnet. And this subnetwork is going to be called architecture for now. And that's going to be our little tool. And then I want to have those two boxes. Let's make them intersect. So they are very similar to what we have done in our example. The example I've shown you in previously. Alright, so we have two boxes. Let me visualize the box. Let's move them around a little bit. And let's make them a little bit bigger. Let's move you up. So that's the first one. And then we have the second one. On the one hand, we're sticking to boxes, but we are allowed to rotate them along their vertical axis. So that's nice. It's already creating a little bit more of interesting shapes. And a little bit more over there. Let's move you upwards a little bit. Yeah, that's fine for now. That's already maybe a little bit more like this. And yeah, let's for now, this is fine. Doesn't really matter that much actually. Alright. What do we got? The L shape that I wanted, which is the most important thing. And this is also sort of an L shape. Those L shapes are very common in a sense. I can also show you later how to do this with a terrain, or you can imagine how you can also do this with terrain. But for now, let's just dive into this as an example. And we're going to lay out the system that we will be making. And the first step is going to happen in a subnetwork, which is kind of the cleanup phase. Especially if you're getting stuff from Unreal or from other artists or however your pipeline works. Usually it's quite healthy to have this little cleanup phase, and we have a boolean as well, which we will do. Cleanup boolean. That's what we will be doing over there. Then I want to have a subnetwork where we do all the dividing of these facades. Divide facades. After that, we will have a step which is going to be segmentizing. I will explain exactly what it is a little bit later. But that's easier to explain once we have some input for that. And this is going to be segment creation. And then we have a final one. And this is where the actual placement is going to be happening. Placement. Alright. So those are the steps that we are going to be taking. And let's just go into the boolean for now, because that's also the easiest one. Because for us, we don't really have much that we have to do. So let's place down a boolean node. And what this does, if we set it correctly, we can just have union. And let's hide other stuff just to make sure. And you can see now that we have one manifold shape, which is nice. And we have those facades actually to be L shapes instead of just looking like an L shape. There's now actually a polygon shaped like this, which is very nice. Next up, what I want to do is kind of recognize the different things that we're working with. So we're going to give some groups to the wall, to the roof, and to the floor. And to do this, I'm going to place down a group node. I'll call this one group roof. And I will do this by keep by normals. And this should give me all the top facing primitives. I'll call this roof. We will also do this for the floor, which is very similar, but we are now pointing downwards. There we go. And now I'm going to have a combine. Let's also rename this to be floor. And now I will place a group combine, which is a nice node to do some logic on the groups we have. And the group that I want to create is called wall. And it's going to be equal to everything except roof, and an exclusion with floor. And this should give us a group which is everything except the floors and the roof. Alright, that means that I have my group set up. Let me select these nodes. I press A and I move upwards so I can nicely align them. Let's actually use the output for that as well. Oh, and let's wire it up correctly so it does this correctly. There we go. And perfect. Now we have our little cleanup done. Well, we didn't really do cleanup, we just prepared with the boolean. And this is going to be going into that divide facades subnetwork. And now we're going to be going over what I've been drawing before. We're going to be dividing up these systems. So let's dive into this node. And we will place two different subnetworks. The first subnetwork we will call horizontal division, and the second one we will call vertical division. There we go. Let's do the horizontal one first. That one is a little bit easier and really will show you how it works. So we have to figure out where do we want to do horizontal cuts. The first thing that we have over here is going to be a for each primitive. Later we will change this for each named primitive, but for now this is fine. Let's wire this in. And now we can start looping over everything. Oh, and what we also need to do, of course, we're doing only the walls right now. So let's place down a blast. Let's keep everything which is a wall. And now if we go to single pass on this for loop, which is set to be running over primitives, we can loop through all the different ones. And let's keep one L-shaped one to start with. And what we want to do, basically what we want to do is have this horizontal cutting plane over here. Well, there's a bunch of ways in Houdini how you can divide up a primitive. And the one I want to teach you right now is the one with the Voronoi fracture node. So imagine that we have this, and I'm going to place a Voronoi fracture node. This one basically uses points as input. Because you might have heard of this node, and a very standard way to use this is to place down a scatter first, wire in the primitive, wire in the primitive, wire in the points, and then look at the result. And we have this, this very standard Voronoi pattern. But what I would like to do is to use this Voronoi fracture node using 2 points as input. And I'll show you what happens. So imagine if I have this point. This point is going to be our cutting plane. And the second thing that I want to do is place a transform below this add node. And another transform. And the first one is going to translate it down by 1. And the other one up by 1. It's kind of arbitrary how large the number is, as long as they are the same. I will merge these. And I'll throw this into the Voronoi fracture node. And now you won't see anything because our cutting plane is at 0, but if I move it upwards, you can see that we have a very clean cut. And it's mainly clean because when we actually hit stuff, this is where a lot of divisions really go wrong, when we are trying to cut a plane which is concave and we have some like overlapping edges. The Voronoi fracture node has an option for us to have this cut plane offset, which can help us survive these really annoying moments, because right now we can just set it up to be very, very tiny, and this is just for yeah, you have to tweak it a little bit to whatever feels nice. But this really helps to, even though you get a little bit of space over there, which there are ways to remedy that in a healthy way. What we have done is really just not bothered with all the difficult mess that we get when we have a cutting plane going exactly through a line, which can give very unhealthy geometry, and trying to recognize that is basically not worth it. Your original cut needs to be clean. That's one big take of mine, in my experience at least. So, this is the way that we want to add this cutting plane. But right now I'm just doing it manually, which of course we're doing Houdini. We don't want to do this stuff manually. So what I wanted to do, because right now we're already looping for through all the different planes. And do I want this plane to exist on every other plane? No, I just want to keep it on the current one, so I need to get it from the current primitive. And what I can do is place down an add node. Delete geometry, but keep the points. If you look at this, now we have a bunch of points. And what we can do is place a fuse and first a transform. Now we're gonna get rid of some redundant cutting planes. And I want to scale everything horizontally to 0. And now I want to place a fuse. And now we have a couple points less, which is nice. And for each of these points, we want to add one cut to our original plane. So we need another for loop. And what we want is to loop over these original points. And this is where it's going to get the most confusing, as we're going to set up this for loop in a quite interesting way. Because what we wanted to do is to go over all the points. So I'm going to set it to points. And I want this repeat begin to be set as the piece block path. I'm going to rename it to cutting planes, because as we learned that one point can be defined as the cutting plane. And now we also need as input the actual primitive. But we want to remember that we are doing this stuff for the primitive. So I'm going to copy this one over. And I want this other one to be the plane, the facade. And inside of this for loop, we're going to wire this as the default block path. And this one is going to be fetching feedback. So we have this top one is going to be set to extract piece or point. So this one will fetch a different point each iteration and really determine how many iterations we have. And then whatever goes in here is coming back out of this second place. So that's the most confusing thing. Which if you've done normal code, it might seem very natural, because it's basically we have stuff that comes from inside of the loop and outside of the loop, which is totally fine. But right now we basically have an interesting for loop setup. So we want to set up the same system, because we know we have our original point over here, which we need to do the same system as we have done over here. So let's wire this up. And we know that they are always horizontal, because we are making a horizontal division setup. And this of course needs to go over here, and for this fetch feedback we need our original primitive again. Let's remove that wire. And let's wire this up. Alright, so let's just go through this system so we can see what's happening a little bit. So over here we should have our plane actually. Oh, let's have a look. I've probably done something wrong. Let me reload this thing to see if this is correct. Looks like I have this one not completely set correctly. We have the piece path, which is correct. Feedback iteration, which is also correct. Extract a piece or point. That one is correct. Of course, we don't really have anything over here yet. So let's have a look at the first iteration. single pass. So now we have the very first iteration. This one is correct. And this Voronoi was set up incorrectly, because to the left is where we need to have the input of the cutting plane, which is coming from the right. So this is our original input currently. And we can see that because our for loop is set to single pass. So we have our original primitive coming in. Then we have our cutting plane being split into 2 points, because we basically have 2 Voronoi cells which are going infinite to both ways, which are now creating that cutting plane. And this one you won't really see because it's there at the bottom. And that's totally fine, because we will only see the one which is the second iteration apparently over here. And perfect. Now we have this fuse we can play with a little bit. Or we shouldn't. Let me have a look. Yeah, so those two are a little bit close to each other. So I think that my original piece is actually not straight up. I accidentally rotated it a little bit. Let me have a look. Yes, that's what I did. Let's move this back to 0, because I only wanted to rotate the original piece around their vertical axis, so they stayed horizontal. That explains that mistake. Alright, let's go in. And now we have if we reset this and reset this thing. Let me make sure to reset this correctly. This is set to single pass, perfect. And now this one is set to be the second one, which also works. And you can see that we have our horizontal division. We can actually remove the single pass one, because the first and the last one don't really do much, which is totally fine. Alright, we have set up our horizontal division. I will clean this up a little bit later. So in the file you can get with these tutorials, you'll have a little bit of a cleaner overview, but it's still exactly the same. And then we have the next step. So right now we're still doing it only for one, which will make a bit more sense later. But right now I want to do the vertical division. So let's go into this vertical one. And we're going to set up a very similar system. So we can actually, instead of doing everything again, let's just copy over the horizontal division. And we're going to make some adjustments. Alright, so let's place a null so we can look at our input over here. And let's make some modifications. So the first thing is, like, we now actually care about because we are going to have vertical divisions. We care a lot more about where they are vertically. So this transform doesn't make sense anymore. And we have another problem, because right now we have our input face, which is, let me have a look. We have our input face over here. This one doesn't work anymore because we have only one input. But we have our input face. And I want to have a horizontal division. So I need to place those 2 points again. But right now it's not as easy as placing 1 point a little bit higher and placing 1 point a little bit lower, because we don't know what is right and what is left. So we somehow need to know what is right, what is left. And we need to figure that out. Well, one way to figure this out, so we won't use these transforms right now, we will use something a little bit more fancy, is to basically get this the forward of our plane. And that's what we're going to be using. So what I want is to set this as a detail attribute. So I have an attribute wrangle. What we should know from the beginning of this one is that, because we have already separated the two of these, you can see that we have only one primitive over here, which is totally fine. But what we want to do over here is keep track of our horizontal one. So we need to forward of our primitive, basically the primitive normal. And we can place a normal node to actually get that normal. Set it to be primitive. And set it to by face area, because this helps a lot if we have a lot more points and some points are close to each other. It sometimes does something weird. And setting it to face area solves this. So right now I have a primitive normal going outwards, which is the one that I want. Because later we're going to play with those vectors again. I'm going to attribute promote this because I don't want to lose it in any way. I'm going to promote this to detail. And let's grab the correct name, which is the normal, which is N. Set it to be a detail. And I'm going to call this forward. And right now we should see probably this an artifact of using the normal for this. Let's see if I can just already call this forward. And let's have this also be forward, and then I don't need to rename it. Alright, let's see if I'm setting it correctly. So I have the forward over there. I wasn't doing it from the primitive. That explains. So now we have a forward vector which is going outwards. Perfect. So that's the one we need. And this is basically added to everything, so we can always access this as its detail attribute. Now we don't need these transforms anymore because those don't really work nicely to do this vector operation. I'm going to place down a point wrangle to switch it up a little bit. Could also do this in VOPs, but just switching it around a little bit. And what I want to update is the position. So to get the position inside of a wrangle is P, and I want to move this. So what I need to move it with is basically the direction that we have, which is sideways. So how do I get this? You can imagine that I have this forward and I have an abnormal, and if you remember, we have a cross product to get now the sideways vector. So how I'm going to call this? Vector side is going to be equal to this detail attribute. So let's first grab this detail attribute. So we have vector forward. It's going to be equal to the detail attribute on itself, which is called forward. And right now we have with the up we can figure out ourselves because it's up. It's always pointing upwards in our example. So we're going to do the cross product of our forward together with the side. And not the forward and the side, the forward and the up. And the up is equal to 0, 1, 0, as that's the direction which is going upwards. 0 in horizontal, other horizontal also 0, and just in the y direction we're going up 1. Alright. Now we have our side direction. We also, one thing we can do, if you're not, right now we kind of know that it is as a length of 1, but you can normalize it if you're unsure if something might be wrong, or wherever you're getting this this direction from, just to make sure it is they have both the same length, because that's kind of important for the cross product. And what I can do right now is to grab our position. I'm going to do the plus equals, so I'm taking the original position and adding something to it. That's what the plus equal sign stands for. And I'm using this side vector to move it. This means that if I have a point, an original point, because we're still getting those original points, and this one is coming in from the corner, so let's visualize our original primitive, and that's the corner one we have over there. And we want now a cutting plane, which is not really doing anything, but for the sake of what we're doing, we still want to set it up. And we want to move this sideways, which is what we can do with this little piece of code. Currently not a lot of stuff is happening. Let me check what's going on here. So we didn't move it by anything. Let's just write down these attributes to see if we... I see what's going on. I didn't reload the for loop, so I didn't have the forward one yet. And now you can see that by 1 we have moved it to the side. We're going to do the same again for the other direction. We're going to do a minus sign. And let's wire those up instead of the transforms. So it was a little bit more effort to get the sideways pointing directions, but still very doable. And now you don't really see anything. And let's make sure that we fix that as well, so you can actually start seeing something. So we're going to skip this horizontal division at the moment. And that already works. You can see that we have our horizontal one. One thing that I can see with this flickering that I forgot to do is to go to the Voronoi fracture node. And I don't want to have this interior surface to be created. So let's also do this for this previous horizontal one. Let's turn off interior surfaces. Let's visualize them again, and let's rename this to be vertical. There we go. And now we're going to make another modification, because what you could already see is that when adding this vertical operation, you could see that it didn't add something over here, because this is now one primitive. And that might not always be the thing that you want to do. So maybe it is, maybe it isn't. But let's place down something that can fix this. And we're going to place down a unique identifier. So we're going to loop over this entire group instead of just each separate primitive. By placing down a prim wrangle, I am going to add a attribute which is called facade ID. It's going to be equal to the prim number. And right now I'm going to dive into these loops, and I'm going to remove the single pass as well. What I also want to do is to do a piece attribute. Instead of just running over the primitives, I want to run over facade ID. Which for the very first operation, the first time we do this, it doesn't really change anything. We still get the horizontal ones. But for the second time we do an operation, it does matter. Because right now you don't really see much of a change anymore, because those are now separated. But if we want to group them, these two, to their original facade again, we can use this facade ID attribute. And now we've grouped them again. And let's just dive in and see why this is working. Let's do a single pass. What you can mainly see is that right now, if we do a single pass, it has grouped them together. So if we go into the input, you can see that we have the two of these grouped together, which means that all of these points, also this point 2, which is not actually used in the top primitive. This bottom point is only used for the lower primitive, but it's now used to also do a division for the top one. And that's the core thing that I was after. So now we have set up two systems which can help you to divide up your shapes. Let's make this a little bit more interesting. So we're going to go to our cleanup boolean. I'm going to first add a little grid. Let's do that up here actually, which is going to be our very basic terrain. Let's up the resolution a bit, and let's place a mountain node just to show it works. Alright, now let's make sure that we are actually going through. Let's move it upwards a little bit. And let's do that element size, amplitude, maybe a bit more, or let's just play with it a little bit higher and then a little bit larger. Yeah, now you can very clearly see this detail. And let's wire this in. So we have now our second input, which is going to go into this cleanup boolean. I want to place a poly extrude. And what I want to do is basically extrude this shape downwards, as the boolean really likes manifold shapes. And let's just put this downwards, but you can see this is already not that nice. So what we actually need to use is we're going to do a point normal and to use an attribute. And now with a point wrangle, we're going to force this direction to be downwards. By setting normal, it's a vector, and it's going to be equal to 0 minus 1, 0. And now we have a direction going downwards, which gives us a better shape. Let's make sure that we also output the back. So we have a manifold shape. And we can give this normals again. Doesn't really matter because we don't use them, but then you can see what this shape is. And we're going to put this inside of the Boolean. Well, let's for now place another Boolean. I like to keep these steps separated so you can play around with them later if you want to. And what we want to do is a subtraction of A minus B, which is not true. What we want to do is looks like I have this is an intersect operation. So this is, let's see if we can fix this by placing normals on the left side. There we go. What I see what happened. I'm a little bit too high up. I poly extruded not correctly. As we see that we have our input shape and I went upwards instead of downwards. That explains it. And now I do want to reverse this. And then place the normals. Oh. Ferocious shaking, as always. There we go. So, that's the terrain cut off. Now, we still want to check if we are recognizing our floor correctly, because I haven't really fine-tuned those values. And let's have a look over here. Let's mainly see with a group promote if our walls are intact. It should be fine. Let's set this to be primitive, so nothing is really changing. Yes, that's all perfect. All right, and now if we go into our divide facade and have a look at what's happening over here, and we want to make sure that we are doing this for everything, so that's fine. And then we have our verticals, and let's not do a single pass. And right now, doing this operation for true groups might be a little bit too much. It also looks very cluttered in a sense, and this distance value is way too high for an operation like this. But for now, let's not worry about it too much. Let's just go over what is interesting about this. So one thing which is important is if we just do the horizontal division, it can become very strange in a way. Because right now, the way we are dividing up this spot is by having these basically horizontal gaps. Like this piece is kind of hard to connect to the one on the left. If you're just placing horizontal beams, that's totally fine. But depending on what you want to do, it's sometimes more sensible to do it from a vertical approach, which gives a bit of a cleaner result. And also one thing that we can do is do multiple steps. So right now, this vertical division is just looking at every point to do a vertical slice, which is maybe not what you want. Maybe you don't want to care about it too much yet. So what we're going to be doing is doing these horizontal ones. But we don't actually want these horizontal ones right now to look at all these terrain points. But we do want to have some horizontal slices. So we need to know which points are actually part of this horizontal group. So this terrain group. So let's make sure that we have a group over here. Let's call this terrain. Let's set it to primitives for now. And this means that if we do a group promote below here, and let's grab the terrain. Oh, it's a roof, it's not terrain. And I want to set it to points. Now we have a group of points which are part of the terrain, which is exactly the thing we wanted, because we might want to exclude this. So now we have terrain points over there, and now we're gonna go to the division stuff again. We have our horizontal division, and let me just save real quick. And over here, all the points that we want to keep, we could place a blast to run over all points except the terrain points. So we're just gonna delete all the terrain points. which is going to make sure that there's not actually that much left. And right now, you can see that we still have these horizontal divisions, just like over here, but we don't have all the other ones anymore, which is, depending on how you want to play stuff, could be very handy. And then we could have a vertical division, which, for example, does do the heavy lifting for all the horizontal divisions. Awesome. So this is the core of the dividing part. Now we also actually need to use these nice divisions to get something sensible, and that's what we will do in the next step. Let's wire this up and let's make sure it's straight. Using the same trick, pressing A and then dragging. And let's go to the next subnetwork, segment creation, because we've done some cool stuff, but still, like how would you use this? And we're going to be playing with vectors a lot again. So next up, what we want to do. This is also a place where our facade ID might become very handy again. So let's place a for loop. And I'm going to set this up manually just to show you how it works. You can also, for example, do for each primitive or for each name primitive. But it's basically the same, but then you have to you don't have to set these settings manually. I want it to be a piece or point primitive, and I have this facade ID again that I want to use. And this means that if we have a look at this, and I need the piece block path to be set. And now you also know why there are two of these, because you've seen in the Division Maker that we actually used both of them. So that's sometimes very handy. Now, what do we have? We don't want the feedback, we want to merge, and let's have a look at a single set. Oh, did I do something wrong with the facade ID? Let me have a look. So we have our facade ID, and that is, that's healthy. Pieces or point. Fetch piece or point. There we go. A nice reminder for myself. So here we have, for example, one facade. And right now we have this horizontal division as well, which is for now perfect. It's fine. It doesn't hurt us in any way. What we wanted to do is do another for loop. And we're going to be looping over each primitive this time. And this time we do want to loop over each primitive. And what we want to do is to convert this primitive into a line with up vectors. Because right now a primitive, how can we use this to... press the wrong button again. One sec. Alright. Oh, let's hide those. Alright, let me start again. So, right now we have this long shape, and how do we want to play stuff in this? Kind of difficult, like how you could do a scatter or stuff, and maybe that's nice, but I want more control. I want to have the exact same object, but I want more control. So what I do is, let me draw this out. I can to explain this a bit.